Welcome back to Quest Edu Physics students. In previous edition, we have learnt about how to convert one system of units into another. Actually, students, we are doing the dimensional analysis. In dimensional analysis, we can do uh, different kinds of relations and as well as we can check the equations and we can derive the equations also. But here, in this class, we are going to learn about principle of homogeneity. Principle of homogeneity. If you watch this sentence, you will understand principle is principle only, and homogeneity means what? Similarity. How we use the principle of homogeneity, we have to understand. Okay, students, everyone knows that birds of same feather sit together is a proverb, I think. Birds of same feather sit together. Understand, students? That means what? Similar people or similar thing can be added, can be subtracted, can be equated. Understood, students? Understanding me, what I am trying to tell. Similar things can be added, similar things can be similar. Strictly, I am saying same things. Instead of similar, I am using the same. Same type of things can be added, same kind of things can be subtracted, and same kind of things can be equated. The same sentence we are utilizing in principle of homogeneity. Same physical quantities can be added, same physical quantities can be subtracted, and same physical quantities can be equated. Okay, students, but there is no restriction of multiplication and the division of different physical quantities. See this, see the last statement. There is no restriction of multiplication or divisions, okay, with other physical quantities. But what it is saying us, same kind of physical quantities can be added, can be subtracted, can be equated. It is known as the principle of homogeneity, students, and the condition is that different kinds of physical quantities can be multiplied or can be divided. But while we are adding, subtracting, and equating, we have to, what's that? Add the similar. That means same, not similar, it's same. Then the statement can be written like this. What is the principle? Same kind of physical quantities. Note this, students, it is a very important one. Can be, number one, added, subtracted, and the third one, equated. And there is no restriction for division and multiplication. of physical quantities. Okay, students, it is stating us that same kind of physical quantities can be added, can be subtracted, and equated, and there is no restriction for division and multiplication of physical quantities. We can understand this thing very easily, students. We have different physical quantities. It is given like this. Okay, force is given, work is given, okay, energy is given, pressure is given, and as well as velocity. Okay, this represents different physical quantities, students. Force is a physical quantity, and work is another physical quantity. We should not add force with the work. It's the wrong way. You cannot add force with the work, or you cannot add, it is for example one. The second, you cannot subtract force from pressure. It is wrong. And the third example, you cannot, okay, equate work with the velocity or pressure with the velocity. Okay, students. Here it is the principle of homogeneity. Force, here what we have to do? Force can be added with the force. Force can be added with the force. It's right. That means what? Force can be added with the weight. Is that right? Force can be added with the tension. It is right. Okay. Then what can be added with energy? Because both are same. It's right. Force can be subtracted from the force. It is right. Force can be equated with the force. Understanding, students? It is the principle of homogeneity. Only same kind of physical quantities can be added, can be subtracted, and equated. But you cannot add, okay, different physical quantities with each other. I mean, x have to be added with the x only. Okay, you can't count x and marbles together, even though they look the same. Understanding, students? Similar physical quantities can be added, can be subtracted, can be equated. Okay, but there is no restriction of division or multiplication of the physical quantities. Pressure can be multiplied with the volume. It's okay. Pressure can be multiplied with the volume. It's right. Okay, students. Pressure can be divided with velocity. It's okay. But pressure cannot be added with the volume. Okay, students. Pressure cannot be subtracted from the volume. And pressure cannot be equated with the volume. Okay, students. Let's do one problem, students. Actually, the equation is written as like this. Van der Waals equation is given as P plus A by V squared multiplied with V minus B is equal to RT. Find the dimensions of A and B. It is a question, students. This question is asked for so many times in competitive examination, students. When we are studying the same question is asked in IIT students. But at the time, I am unable to solve this question, students. At the time, we have limited sources to understand the physics. Okay, we have the limited edition of the books. Okay, nowadays you can get various publications in physics and a lot of information through the Google. When we are studying, we don't have any such facilities, students. Okay, students. Van der Waals equation is given as P plus A by V squared multiplied with V minus B is equal to RT. Find the dimensions of A and B. In this equation, he mentioned here P stands for pressure. P is pressure, students, in this equation. It means students. And V is the volume. Don't mistake it as the velocity. Generally we do. V is velocity. Okay, students. Only two. And R. R, you know that it is a gas constant. And T is absolute temperature. Okay, students. These are the physical quantities which are involved in this van der Waals equation. And he is asking us find the dimensions of A and B. Okay, students, I told you only same kind of physical quantities can be added or subtracted or equated. Okay, students. Let's do this problem, students. Here, already explained which physical quantities are involved in it. First, we are taking this part. Pressure plus A by V square is equal to constant. We are taking the principle of homogeneity and it can be written as pressure is equal to A by V square and it can be rewritten as A is equal to PV square. And we know that what is the P and what is the V. P is pressure. We are writing the dimensional formula of pressure. Pressure is equal to force upon area. And you know that force has the dimensional formula of M1 L1 T inverse 2, area is L square. Then we had M1 L inverse T inverse 2. It is for pressure, students. Okay, students, and volume. Volume is equal to L cube. I'm writing directly. Here is said it is the square of volume. That means L to the power of 6, students. Now we have to write the dimensions of it. A is equal to PV squared. Pressure we got here M1 L inverse T inverse 2 multiplied with L to the power of 6, that is M1 L to the power of minus 6, okay, students, into T to the power of minus 2. Okay, these are the dimensions of A, students. We got A is equal to M1 L inverse 6 into T inverse 2. And the second part we are taking V minus B is equal to constant. Okay, and V is equal to B. Volume is equal to B. Means what? V is equal to L cube, that is M0 L cube T0. In this way, we got A as M1 L to the power of minus 6 T to the power of minus 2 and B is equal to M0 okay, L cube T0. It is the principle of homogeneity, students. I hope you understand. There is no need of what's that using R and T okay, in this equation. We are not at all equating. Without equating only, we found the values of A and as well as the B. It is the beauty of the principle of homogeneity, students. Then what is telling us that only the same physical quantities can be added. Means what? Immediately after watching this equation, you would understand that A by V square has the same dimensions of P, pressure. In the same way, V is equal to B. It can be subtracted. Okay, students. Let's go into one more problem. And these equations, what we are going to do now, are studied in 9th class, students. Okay. Here, the same thing can be applied for the checking the correctness of equations. Checking the correctness of equations. Okay, students. Here, what I have to say. Checking the correctness of equations. Okay, students. The basic equation I am taking here, students, that is V is equal to U plus AT. V is equal to U plus AT. This is the equation of motion, students. As you know that here, V and U both stands for velocity. And you know that velocity is displacement upon time. And A is acceleration, rate of change of velocity. Okay, students. And T is the time. Okay, students. Here, the dimensional formula. We have to write the dimensional formula of U and V because both are velocities only. Here, V is the final velocity and U is the initial velocity. Know that velocity is equal to displacement upon time. Okay, students, displacement is L by T, that is m0, L1, T inverse, and we had acceleration. Acceleration is what, students? Acceleration. Okay, we show with small a is velocity upon time. Okay, students, already we got the velocity, dimensional formula of velocity, m0, L1, T inverse divided by T, that is m0, L1, T inverse 2. Okay, students, now we are substituting the values and time. You know that time T is equal to what we have, m0, L0, T1. Okay, we have to equate them. We have to show V is equal to U plus AT. What we got? Velocity m0, L1, T inverse is equal to U, means m0, L1, T inverse plus A, m0, K, L1, T inverse 2 multiplied with time, that is m0, L0, T1. And finally, it can be written as m0, L1, T inverse is equal to m0, L1, T inverse plus m0, L1, T inverse 2 plus 1 means what? m0, L1, T minus 1 is equal to m0, L1, T inverse plus m0, L1, T inverse. It might be 2 into m0, L1, T inverse. Numbers don't have any meaning in dimensional analysis, students. Finally, we can write m0, L1, T inverse is equal to m0, L1, T inverse. That's why, okay, both are same. LHS is equal to RHS. Okay, it tells us that this equation V is equal to U plus AT is dimensionally correct, students. Let's do one more. Okay, students, the next problem is asking us check the correctness of the equation K is equal to half m square. K means kinetic energy, students. Kinetic energy. What is kinetic energy? Energy possessed by a body by virtue of its motion, students. energy possessed by a body by virtue of its motion. Kinetic energy, potential energy, whatever the energy is, all the energies are nothing but work done. And you know that the dimensional formula of work done is equal to what? Or kinetic energy or potential energy. It is force multiplied with the displacement. That is m1 L1 T inverse 2 into displacement is L, that is m1 L2 T inverse 2. Okay, students, we have to show it equal to half mv square. Numbers don't have any meaning in it. And we are writing the dimensional formula of mass. Another physical quantity I am taking. Okay, what it is? M1 L0 T0. Then after dimensional formula of velocity. V means velocity. Velocity is displacement upon time. That is m0 L1 T inverse. Okay, students? I said numbers don't have any value in. That is, you can write K is proportional to m v squared. Okay, proportionate constant, we are taking it as the one. The kinetic energy has the dimensional formula of m1 L2 T inverse 2 is equal to, for mass it is m1 L0 T0 multiplied with v square, square of the velocity, m0 L1 T inverse squared. It can be written as m1 L0 T0 multiplied with m L square T inverse 2. Then the bases are same. We have to add the powers. Okay, students, it is m0 only. Okay, that is m1 plus 0 L0 plus 2 and T0 minus 2. That is m1 L inverse 2 T inverse 2. See, the same thing is yielded here. That is what, students? LHS is equal to RHS. Hence, dimensionally, this equation K is equal to half mv squared is dimensionally right, students. It is about the principle of homogeneity and checking the correctness of equation, students. We have a number of equations in physics. Take a dozen of half of dozens of such equations and try to check the correctness whether they are right or not by using the principle of homogeneity, students. And one more thing, you can see 3 videos in units and dimensions, same topic, on my YouTube channel, students. It is Quest Shadow Physics. If you like the video, please subscribe my channel to get the notification, students. Thank you for watching Quest Shadow Physics, students.